All right, everybody, let's get started with the Nostr workshop. Everybody ready to start coding on Nostr? Yeah! Hope everyone brought your laptop. There will be coding. We will be typing code while I'm presenting. That's the goal. So have a laptop out and be ready to start typing. What are we going to do? The flow of this thing is going to be, I'm going to tell you just a very little bit about Nostr. We're going to make our first Nostr application together, and then they're gonna move on from there. A couple of announcements before we begin. Next Saturday, there's going to be another workshop called the Ordinals Workshop with Rodamar. I don't know how to pronounce his name, but this guy is going to do a talk on ordinals and how you can use those for assigning ordinal numbers to Satoshis and tracking them across transactions. So if you want to learn more about that and why ordinals might be neat, feel free to come to that event next Saturday, 12 to 3. There's a meetup page if you want to attend. It's another workshop like this, so you'll need a laptop. Yeah, a couple of other things. I'm going to give you guys a sneak preview of a couple cool things. This is the Damus app, which came out recently for iPhone. Yes. You want me to put it up again? One of the things you're going to need is internet access. This is how to get internet access using your device. So is that good? Everyone on the right thing? Great. I will keep this up and need to go back to it. Another mention is the Damus app for iOS is a Nostr-based Twitter clone, and this is what it looks like. It looks very much like Twitter, so feel free to use that and check it out. I also want to show you one of the things we really need help with in the Nostr space is making a desktop application. None of us are very good at that, and what we do have one, somebody is making Future, which is right here. This is what Future looks like. And so you can check that out by going to our Telegram group and searching for it. That is about the only way right now to find this stuff. But yeah, we need help making desktop clients because this is kind of ugly. How do you spell Damus? Damus is D-A-M-U-S. Future is F-U-T-R. So, all right, announcements out of the way. Let's get right into it. Hi, it's Vince with Slap Chop. You're going to be in a great mood all day because you're going to be slapping your troubles away with the Slap Chop. Now look, here's a potato, 1 slap. You got big chunks for stew, 2 slaps, home fries in a second. And look at this, when you add a mushroom, the more you do it, the finer it gets, and you don't have to switch any blades. I'm just doing this because I think this makes me look like a Slap Chop guy. So, this is not a workshop on the Slap Chop. This is a workshop on Nostr. So what are we going to be doing? Let's get into what Nostr is. Before we get into what Nostr is, yet more ado, I want you guys to take a look at this. If you want to have this presentation on your laptop, I recommend that. It makes it easier to follow along, and that you're going to be copy pasting stuff. So this tiny URL, you can just put that into your browser, and you'll have this presentation right in front of you. And the first thing you should possibly consider copy pasting once you're on tinyurl.com/nostr-workshop. Look at all those anonymous animals filtering in. I love it. Once you're on here, one of the first things you should consider doing is copying this link. This GitHub page is what we're going to be building today. Your first Nostr client. And if you take a look at it, there you can actually see the final product we're going to build right here. And this, let me tell you, is a gorgeous interface. This is what we're going to be building together. Can you believe it? I know that for the sake of Ben Carmen, I thought he was going to be here, and I know he doesn't like light mode, so I do have a dark mode version of what we're going to be building today. But actually, all the action happens inside the console. which is where you can see we actually have a public key. We're connected to a relay. We've subscribed to ourselves. We've posted some messages. Here's one of them. And then we posted a private message down here. So that is what we're going to be doing. And yeah, that's what we're building. Let's get into it with the Nostr workshop. All right, what is Nostr? Nostr is, if you look on its GitHub, it will describe itself as the simplest open protocol that can create a censorship-resistant global social network once and for all. I crossed that out because I disagree. That's not what Nostr is. Nostr is, in fact, data storage and retrieval, and it uses a shared global network of dumb relays as that's where you put the data. And I think that is really useful. Because it suggests that you can use Nostr for anything, and it's not just for social media. But social media is the first application for Nostr, and that's a great one. How does Nostr work? By the way, are there any questions about what this means? Data storage and retrieval, dumb relays, anything like that? Okay, cool. Feel free to raise your hand if you have questions at any time and interrupt me, and I'll just repeat your question if I remember to for the microphone and for the people watching on YouTube and such. All right, so this is how a pub sub model works with a client relay model. A lot of people assume when they go into Nostr that this is another peer-to-peer application. And when you're using some of these applications, it might feel like a peer-to-peer application because there's pub keys and you're directly talking to, it seems like you're directly talking to someone. But Nostr is not, in fact, a peer-to-peer application. It uses a client-server model, although in this space we call the servers relays. Your client might be this phone over here, and you got another client, someone else on the side over here, but your client never talks to this guy. Your client talks to a relay, talks to a server, sitting somewhere probably in the cloud somewhere. And what you're going to do is you're going to be user one. You're going to write a message such as hello world. You're going to fire it off to this server, and the server's going to store that. He says, great, I saved that note. And what happens then, some time goes by, represented by this clock. This is time passing. And your peer, the guy you actually want to talk to, he's going to fire off a request to the same relay. And he's going to say, give me post by user one, please. And he's going to say, all right, user one said hello world, like 5 years ago or whenever he did. Because this uses the internet, it's kind of fast. So it can seem peer-to-peer when you're like, you say hello world and this guy sees it like right away. It just shows up on his phone. But it's not actually going directly to him. There's a middleman. There's a relay in between you, and that's why it's a client-server model and not peer-to-peer. This is also called a pub-sub model. This guy publishes data. This guy subscribes to it. He subscribes to a feed of posts by him. And so it's also a pub-sub model. Some people call it that. Any questions so far? I want to go into a talk here about what is this useful for, but I don't have any slides on what it's useful for. You can really use it for anything. How do we do the communication in Nostr? We do it through WebSockets. Clients talk to relays over a persistent two-way connection. Normally, when you go to a website or when you have something like, I'm just going to stick with that. When you go to a website, you do some things called GET requests, where you fire off a request to the server, you hold the connection open until he gives you a response. Like you say, give me google.com. He gives you that HTML page, and you close the connection. You show it to your user. Next time you want to go to a website, you open up a new connection, say, give me twitter.com, and then you close the connection, and you wait until the next thing you want to do. With WebSockets, you keep the connection open. This saves resources. You keep it open, and you can send data back and forth along it without opening up a new connection every time, and it makes things a little bit faster. So we use WebSockets in Nostr. Let's build one. Everyone ready to get out your laptops? No. Austin has a question. What's up, Austin? Yeah. Yeah, every relay sets his own limits. When I set up one for John, I had to choose limits for it. And I think for his, I set like 5 kilobytes is the limit that his will accept per post. But it's really up to the relay. Some of them will do higher limits. For example, if you want high resolution images to be on the relay, you would need more than 5 kilobytes. So yeah, different relays choose different options. Also, a best practice in Nostr, which I will not be demonstrating here, is that you should connect to more than one relay. Relays are very easy to spin up, and there's a bunch of them. I think I have a registry on here. These are some of the relays. This is not even all of them, but there's getting to be quite a few now. And the recommendation is that you connect to, if you're building a Nostr app, don't just connect to one, because that's no different from just having all your stuff on Twitter or having all your stuff on Reddit. Connect to multiple, and then you have data redundancy. Your posts will be stored at multiple relays, and if one of them goes down, no big deal, because it's on a bunch. Make sense? Yeah. So, but let's build one. And so we get into that. Any other questions at this point? All right, great. So we're going to be building the super way, which means it's absolutely ridiculous and nuts. And we'll be coding directly in the browser. So I want you all to open up a new file. I'm going to go over to my terminal and create actually, no, I will do this in a graphical user interface. I'm going to open up a new folder, and I'm going to call it testing Nostr workshop is what I'm going to call it. And I'm going to go in there and create a new file, empty file called index.html. Why not? That's a good name. I'm going to open this in my favorite text editor, which is Sublime, and I'm going to copy paste this code into there. And you should be following along. Where is my where'd Sublime go? Did I X out of it already? No, here it is. All right. So we have started our app, and I'm going to open that up in the browser. Open with Firefox. Check it out. We have already got a blank screen with nothing on it. That is my favorite type of interface. And we're going to open up our console so we can inspect some stuff. Look at that, no errors. When I first did this demo, I errored right away. Yeah, this is a perfect application. There are no errors. Next thing we're going to do is not that. We are going to put some stuff in there. Put 2 script tags in your header. We're going to need a couple of dependencies. This is the Bitcoin.js library and the SecP256K1 library. We're going to use them for creating public keys and private keys. So we'll put those into our header right here. And make sure that we have no errors. Go back to my page, refresh, and I don't see any errors. But now we have public keys and private keys. So you might be wondering, why are you using Bitcoin libraries? This is like Nostr has nothing to do with Bitcoin. Why use Bitcoin.js and the Bitcoin's elliptic curve? Well, it's because Nostr was made by a Bitcoiner, and he's using public keys and private keys. So he used the tools he had available. He's familiar with Bitcoin libraries. He stuck them in there. This has caused some annoyance for people from outside the Bitcoin community who come in, and now they have to deal with Bitcoin stuff in what should be just a peer-to-peer application. But that's where we're at. We use Bitcoin keys, and that's really the only connection to Bitcoin that Nostr has, is it uses our elliptic curve. All right, so the next thing we're going to do is create a private key and a public key. And that's what this does. You can see down here the operative words are key pair, private key, pub key. So that we're going to put a script tag, and I'm putting this in our body. Doesn't have to be in the body, but that is where I chose to put it. And if you want to be like me, you can do that too, because you can put script tags anywhere. Great. So now we have private key, pub key, and if I go back to my page and refresh. Look at that. We've actually logged the pub key that we just generated for ourselves. And this is what we're going to use as our Nostr account. Nostr doesn't do email sign-in, email and password stuff. We just do public keys and private keys. Currently, I'm generating a new public key every time I refresh this page. So if I refresh it a few times, we're going to get a new account, so to speak, every time. And next thing we're going to do is connect to a Nostr relay. So let's do that down here. This is all the code it takes to open up a WebSocket in the browser and connect to a relay. It is not very big. I'm choosing to connect here to relay.nostr.info. If you use the Nostr registry, you can pick from any of these ones. I recommend ones that are not showing any errors. Pick one of the ones that is that has all green dots and use that. But yeah, there are lots of relays and there's more coming up all the time. So feel free to use one of those as your connection point. I'm just going to add those in here, do some indenting. And if I refresh, no errors. Great. We're in good shape. We have actually connected to a Nostr relay. Step 1 of our goal is crossed off the list. Connected to a relay. We're in good shape. Everyone with me? Yeah. All right, cool. Next thing we're going to do is, I forget where we are. I don't need that one. I don't need the Nostr registry anymore. I don't need that. I don't need that. We got that. Okay. Connecting to the relay? I know, because WebSockets are built into the browser. There's already support for them. If you're following along in a different programming language, like Node.js doesn't have this built in, so you'd need to like import the WS library. Or if you were using Python, you'd need like socket.io. But yeah, in the web browser, it's easy because it's built in. Just do new WebSocket and you're good. Next thing we're going to do is add an event listener. This is our subscribing. We're going to subscribe to ourselves or actually no, this is logging messages that the relay sends us. We're connected to the relay, but if it tells us anything, right now we're not doing anything. So let's do something if it tells us something. We're going to log any messages it sends us into our console. And this part down here that says if kind equals 4, then decrypt it. That's for private messages. We'll get into those later, but we're going to log those as well. So put this in our code and we will keep going. I'm going to put it right there and do some indentation to make it pretty. And let's refresh our page and see if the server sent us anything. No, the server has not sent us anything. Why hasn't it sent us anything? We didn't ask it to. So we just connected to him and that's all we did. But the next thing we're going to do is subscribe. We're going to make a subscription and tell it to send us any messages. We're actually going to tell it when we open a connection to you, Mr. Relay, we're going to log that. We're going to log a connection event and say, all right, we opened a connection to him. So let's do that. Also, I have down here, close this bracket for now, but we're going to put more stuff in here later. So do that. Paste it, indent it, save. And now when I refresh this page, check this out. We not only get the public key, we get a little message connected to the relay. And we get a subscription information. This is the relay telling us information about our subscription. We are subscribed to learn any information about ourselves. Any posts by the author who has this pub key, F9C, blah, 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 the relay is going to share those posts with us. Now, who is F9C? It's us. So we just said, hey, if I post anything, tell me what I posted. Pretty simple. In a normal Nostr application, you'd be subscribed probably to yourself, but also to other people. You'd subscribe to your friends and get their posts. But here we're just going to subscribe to ourselves. The subscription has an ID number, which is what is the ID number is 4F8A. Yeah, the subscription has an ID right there, which we generate at random. It's just so that if we have multiple requests to multiple relays and they're all giving us stuff back, we can use the ID number of the request to see which one is which. One, that's what Nostr was sort of made for. Private messages are of kind 4. When I made Bull Run, I didn't want to use either of those because I didn't want my ride requests to show up in like your timeline if you have like a Twitter client. So I used a different kind. I used like 40 or something. But you just pick a kind for events. Usually you're going to want kind 1 or kind 4, which are public events and private events. Then you've got tags. Usually you put, if you're replying to a Nostr post, you'll put its hash in the tag field. And that then clients can say, okay, I'm going to represent this as a reply to this event. Or you can sometimes put in someone's public key if you're sending a message directly to that person. And then they know, since they're subscribed to themselves, they will see your post because it has their pub key in it, in the tags. And then your content, which is a string. whatever it is that you want to say is going to go into this bottom field right here. We hash the event, and we assign that, and it returns an event object. Next thing we need to do is copy paste this into our stuff. So we're going to put this right above our closing script tag, not yeah, that's where we're going to put it. Let me go into here, and this is, you'll notice this is outside of that bracket we closed earlier. This is a different function. So save that, and let's go back to our page and make sure we got no errors. Yay, no errors, just a connection to the relay, and if we get any messages, it will now send them to us. Let us fire off an event. Put this stuff inside of the open event listener from earlier. And then, so I'm going to put that right here. And there, I think that's good. So we've got an event that we're creating here. The content of the event is going to be, this workshop is awesome. We're giving it a timestamp of right now, and we don't have any tags. It is a public post, so it's kind 1, and the pub key we're using is our own. Then it's going to fire this off to the get signed event function, which we created down here. That's going to get a signature and append it to this stuff, and then we should be good. So let's run that code and see what we get. Hopefully, we will fire off an event. Yes, we did. And the relay got our event, and then because we're subscribed to ourselves, it fired it right back at us. It said, here's your event. I took the content of that event and said, this workshop is awesome. If we inspect this object, this is what the relay returned to us. Just a second for your question. The content field is right here. That's what we sent. That was what we told it to store. This is our timestamp. This is the hash of our event. And this is how the events are identified on the network. If I go take this event and go to like another client such as Nostr.com, I can paste in my event ID and hit go, and it found my event. This workshop is awesome. This is public on the internet. Everyone can see this. I can even check my signature and say it's a valid signature. So that's kind of neat. It's public on the internet.
So
and
the reason that you're signing this private key is to always be able to verify that.
Yeah, we don't like impersonation in Nostr, and so we make it hard to impersonate people by making by doing public key signature, elliptic curve digital signatures. Any Dusty, you had a question?
Oh yeah, can we send each other messages?
Yes, you can.
Am I skipping ahead?
No, that you can do that when we're in the workshop part, or when you were in the part where you're making your own code. You can send each other messages, and that'll be really fun. I hope someone does that. I hope you do that, and other people. But we do got to keep going. Any other questions so far? Good. Next thing we're going to do, so you should see a message in your console that says this workshop is awesome. And in my example here, we do see that right here. Does everyone see that on their own page? We all on the, good? Cool. So the next thing we're going to do is do a private message. That is the next thing on our list. For private messages, I have this additional library called Browserify Cypher. So Cypher is a library from Node.js. Some Node.js libraries you can make work in the browser by putting Browserify before them. And this is one of the ones that works for. This is going to help us with encryption. Topher and I tried to figure out how to get the encryption to work using the browser's built-in libraries, but I couldn't figure it out in time. So I'm using a library that I already knew works. Sorry. But yeah, we'll put that up in our header file right here. So now we can do encryption. And then we need a few encryption functions. We need to deal with hex when we're doing encryption. So we're going to put these functions right above our script closing tag. So that is right here. Let me just indent them properly. Paste that. So now we can deal with hex. Let's make sure that didn't cause any errors. Nope, everything is good there. Then we're also going to need to deal with Base64, which is yet another encoding format. Encryption is hard, guys, and this is, I'm trying to make it easy by just giving you the fun things you need. But here is some encryption stuff. Well, actually, this is just encoding stuff. But we're about to get to the encryption stuff. Make sure there's no errors. Good, no errors. And then this is the encrypt function that we're going to use. We're going to put that right above our script closing tag. What's it doing? Well, it's kind of obtuse, but basically we use elliptic curve Diffie-Hellman to get a shared key that is created using our private key multiplied by our recipient's public key. In our application, we're going to be the recipient. We're going to send a private message to ourselves. Thus, we're multiplying our private key by our pub key. After we have the shared key, that's what we're going to use to encrypt the message to. But we use the encryption function, which needs an initialization vector. We get that by passing some random values into a byte array. And then we use the cipher library to do some AES encryption. This part loses me. I don't know the magic of encryption, but it involves lots of multiplying. And what we get out is an encrypted message, and we specify the initialization vector for this, which is a number you need when you're trying to decrypt the message. We specify that as if it was an array parameter, or as if it was a parameter in a URL. We just stick it right onto the end of our encrypted message. But I will show you what that looks like when we get to that part. So let me add this to our code. Paste, indent it properly, and save. Make sure there's no errors. Good, no errors. And then we have a decrypt function, which we are going to use to decrypt stuff that other people send us. It does very similar things, but it's just the reverse of encryption. It gets the initialization vector and the encrypted message from the content field of the event of the Nostr event. Then it gets the shared secret by multiplying the recipient's private key by the sender's public key. That way they get the exact same thing, because that's how Diffie-Hellman works. It uses the cipher library to decrypt it using the same AES encryption, and then it passes out a decrypted message as plain text. So that's what it does. And let's save that, make sure there's no errors. Good, no errors. Errors show up in JavaScript as like a red bar where you did something wrong. And that would be in this console over here. But there are no red bars, so we know there are no errors. Next thing is to actually fire off an encrypted message. So I'm going to put this stuff inside the open event listener from earlier, where I said keep that bracket available for use later. So where was that? Right here. I'm going to pop that in right there and indent it properly. Oh, one too far. I think that's right. No. There, that looks right. So I'm wondering if I'm indenting properly. That's good enough. Save. And if you want the prettier version where the indenting is done properly, I think I've already screwed up the indenting. There's a prettier version on my GitHub that I put in the beginning of this PowerPoint. So hopefully this won't give us any errors now that the indenting is done improperly. But let's save it and run it. And we should see a private message. Yes. Okay, so we got another event back that we fired off, because we fired off an event first. And you'll notice that this event, yes, kind4 is an encrypted message in Nostr. So you'll notice that, not that one. This is our public message, and the content is in plain text. This workshop is awesome. Now, if you go to this equivalent line down here, the content now for this private message is this gobbledygook with an initialization vector appended onto it as if it was a URL parameter. But that's how we do it. My browser then took this string after it verified that the sender really sent that using the signature. It took this string, passed it into the decrypt function, and then got out the plain text. And so it shows me this message is super secret. And that is, so now we've done it. We've connected to a Nostr relay. We fired off a public message. we've subscribed to that public message, so we got our own, or we've subscribed to ourselves, so we got our own messages, and then we sent off a private message, and it all worked. And that is, if I want to show you, if we took the ID number for this private message and popped that into another client, so I'm going to pop it in to nostr.com and hit go. This one shows that it knows it's encrypted. It knows it's an encrypted direct message because it's kind 4 instead of kind 1, which are public. But it can't read it. All it sees is the gobbledygook because it doesn't have our private key. And since this page doesn't have our private key, it can't decrypt the message. It can check that the signature is valid. So it says valid signature, but it doesn't know what we said. So that is how you do encrypted messages in Nostr, and that completes the workshop. In 120 lines, we have created our first Nostr app. Now it's your turn. You've got all the time in the world to make a better one and do something really cool and make the next Twitter, or the next Reddit, or do coin flips on. Yeah, no, not the next. You can do the next coin flip orchestrator coordinated thingy. Yeah. Any questions?
Can you do like a signal app out of this, or like something similar to that?
You could. Yeah, you could do a signal app.
Without a phone number, right?
You would have no phone numbers. You just have public keys and private keys. I do want to mention some things about Nostr is not perfect for direct or for encrypted messages. Some of the things that get leaked when you do a direct message, private message. Well, it's actually all on here. You leak the author, like that's my public key, and people know that if they know that this public key is me, and they know that I sent somebody a direct message, they also know the recipient. So there's a tag down here that includes the public key of the recipient, and so they can actually see I sent an encrypted message to this person. If they know who that is, that could be bad. Like, what if that's a terrorist, and then you get bombed or drone striked because you're not supposed to talk with terrorists? That could happen. You also leak the length of your message. Like a really long encrypted message would have a much greater length. So 3 of the things that you leak in Nostr when you're doing private messages with people: you leak yourself as the sender, you leak the recipient, their public key, and you leak the length of your message. And there are various proposals for how to mitigate this. It would be great if you are going to build a Signal client, you might want to pad this, like always make the messages of the same length with by putting like extra zeros at the beginning or something. And that way they couldn't tell how long your message is. You might create a new public key every time you send somebody a private message. This is called Diffie-Hellman key ratcheting, and it's used in Signal. It's part of the Signal protocol to do that, so that so they don't know who's messaging who. You might send your private message to 100 people instead of just one, and knowing that only one of them will actually be able to decrypt it. And that way they would not be able to identify who the recipient is. They just know it was one of this list of 100 people. But yeah, there are some considerations if you're going to build a privacy app. I told in discussions with Fiat Jeff, he said, "Why are you trying to use Nostr for privacy? Just tell them your Signal info and then talk on Signal for privacy. Like that would be pretty simple. Or spin up your own relay and say, talk to me at this relay. That way I know I won't dox myself." You have a proposal?
This might be a feature for back office communications between a company. A lot of times, big emails are used from executives to steal funds. This could eliminate a lot of that risk for back office.
A valued audience member pointed out that one problem faced in the world of business is email spoofing. You can spoof an email address, but you can't spoof a private key on Nostr. And so maybe this could replace email communications in offices. You could make an application where you talk to your employees by means of some chat client built on Nostr, and then you don't have to worry about like the secretary getting a fake message from an outsider who claims to be the boss and he wants you to go buy 1,000 Kohl's gift cards. You don't have that problem because you could just click this button and be like, you're not my boss. Don't have the right signature.
Is the encrypted message the length of it?
You didn't raise your hand. Dusty?
Thank you. Hand raising already writes. So in the filter area, there's an array where it says author's pub key. And I thought it'd be fun to remove that. And then I got a lot of spam really fast.
Yeah.
And then, but my real question is like,
Well, let me repeat that for the audience. Back when we subscribed to when we put out a subscription on Nostr, which I think was right here, we created a filter, and we said, don't send us everything, Mr. Relay. Don't send us everything you have. We want you to filter and only send us stuff by whose author is this pub key, which is ours. Our friend Dusty decided not to do that. He removed this line. He just commented it out like this. And then when he did that, the relay dutifully sent him everything it had, because he didn't specify. He just said, send me stuff. I realized, all right, here's a flood. From the beginning of that relay's time, he got Roar. Yeah, it'll send you everything. Well, I'm sure some relays will only send you 1,000 events at a time, but I don't know. It depends on what relay you're connected to.
What I wanted to do is like a tag, superclass.
Yeah.
Is there a way to do that?
So he asked if there is a way to filter a tag. Yes, there is. And one thing you're going to want to do if you're building stuff on Nostr is go to github.com/nostrprotocol/NIPS. These are the Nostr implementation possibilities, and they specify the spec. Yes, fiatjaf's NIPS are online, and you can find information about how to query for various things in here. If you're going to search for tags, you can do tags on a certain event using the e tag, where you say, I want you to return me events that have this ID number, and then it'll only send you specific events. You can specify by a pub key and say, I only want to get events that have this pub key. One of the filters you can do is a content filter. You say, this is NIP1. One of the things you can filter by is a content filter. And you can say, only send me events containing the word ShamWow. And then the relay would dutifully do that. You can also we have a since and until. You can say, only send me events after this certain time, or only send me events up until yesterday. You can do a limit. You can say, don't send me a flood, send me only 1,000 or only 500 or only 100. That's useful if you're building a Twitter client. You don't want your person to have an infinite scroll. You want them to eventually reach a bottom. Maybe you do want an infinite scroll. That could be a feature. Yeah, so we have lots of filter options that are supported by relays, and you can use those. But yeah, check out the NIPS for more info on that. There's a bunch now. Austin.
So the encrypted, when you have an encrypted message, that becomes an endpoint on any relay that stores it, right? So if I go to a relay that's storing my encrypted message and I put that encrypted message as an endpoint, it'll serve it to me, but not encrypted.
There's no endpoint.
It's not an endpoint. The only endpoint is the WebSocket of the relay, and you pass data to the relay that says what information you want back. To get encrypted messages from, let's say, fiatjaf, you'd have to subscribe to fiatjaf, and then you would get his encrypted messages from him.
Okay, and I can just filter by kind.
You could filter by kind 4 and say, I only want the encrypted ones by him. And then if he didn't send them to you, you would just see the encrypted blob. You wouldn't be able to know what the contents were. If he did send them to you, then you could decrypt them because you have your private key, and that's what they're encrypted using the shared key created from that. Any other questions?
Yeah, can you check?
No, Keon raised his hand and you did not. Keon.
Like identity management, you're using pairs for your identity. What kind of practices does the network community have around maintaining your identity, whether wallets or?
Yeah, a lot of them show you your private key and your public key just on. I'm trying to. Let me do it differently. I'm going to go to astral.ninja. So, look at that. You guys can see my toes. So this is one way that it's done. You have a screen that shows you your public key and your private key, and I think there's a generate button on here somewhere. So I just generated a new private key, and it'll just be like, save this. You can do that. Other clients, I think Brandly is a client that shows you 12 words, 12 backup words, similar to a Bitcoin wallet. So if I click generate on here, no, this one just shows me a private key in hex. But you could have a client that shows you 12 words. I thought Brandly did that, and apparently it doesn't. Maybe it used to. I don't know if it seems like the standard is to just give people their private key and tell them to save it somewhere. Does that answer your question? Yeah. When you move to a new client, typically you bring your private key with you, you pop it into the new client, and then it fills up your feed with all the stuff you subscribe to. Yeah. I think it can be improved. Therefore, it's not ideal. So you can come up with a better way to do it. That'd be great. We welcome your NIPS. He still didn't raise your hand. It's this guy's turn now. Constantine. Constantine.
My question is about NIP5 and how
Yep.
work.
I did not cover that.
Is that like a preferred way to find people to their pub key or a little more friendly? Or I seem to be able to search by name, but that's not.
One of the I'm trying to find the NIPS.
Private keys to DNS.
NIP5. Well, that didn't work. Nostr protocol NIPS. Is it 05? So one of the features that is loved and hated on Twitter is the blue check mark that celebrities get and normal people don't get. And we decided that we wanted people to hate Nostr too. So we made that. We made blue check marks. And how we do it is through domain names. If you have a domain name, you can put a JSON file at a particular spot on a particular path on your domain name, and clients know to query that path and find your pub key there. And if they find your pub key, and that means that the owner of that website intentionally put their pub key at this specific path, and therefore they approve of showing that domain name as with a green check mark in Nostr. And Nostr will say, like, this person has been verified to own fiatjaff.com, for example. And then you get a green check mark.
My question is more about means of finding other than
Yeah, you still query them by their pub key, but the client can display then that this person owns or has some affiliation with that website. No, not all clients support NIP5 yet. Some do. Damus does. So you might sometimes see people in there with a green check mark or a blue check mark or whatever.
So the name is simply for display purposes, not search by.
I don't know if it can be searched by. It might be searchable. I don't think there are any relays that go out and check NIP5 identifiers and then store them for querying. Okay, so Astral does then. Astral somehow manages to search that way. They might do it on the client side somehow. Like Astral might map public keys to websites if someone's used the NIP5 thing, and then when you search for the identifier for the website name, it like looks up which pub key that is and actually does a search for that pub key. It might do that.
So you can see all the things that you're talking about this workshop. That's kind of cool.
Isn't that amazing? Interoperability is great.
Open protocol.
I love it. Topher or Constantine or whoever.
I was wondering if you could over NIP12.
I don't know if I've ever read NIP12. Generic tag queries, relays may support subscriptions or arbitrary tags.
So you can tag your posts, and then you can query based on the tag.
So a
Yeah.
hashtag.
You could, yeah, there is, the tags field is designed for doing stuff like hashtags, but the only ones we initially put into relays were pub key and events. So I think this is to give a generic hashtag thing and make that searchable. It sounds like what it is to me, but I have not read it. And so if someone from the Nostr community wants to correct me, Nostr is the place to do it. Dusty Detmer.
There's two points I've learned from the Nostr stand that apparently web labs is now here.
Satoshi's what is here?
Satoshi's here and placing bomb. Okay, what are you doing?
Satoshi's in this room, and that's cool. And splicing is the bomb. That is what a valued audience member had to say.
I have a proposal. We pick a times number for our class. How about 1337? Go with that on our messages. Separate ourselves. Yeah, that's true.
Yeah, if anyone wants to do that, that'd be great. Just modify the client. It's only 120 lines of JavaScript. You should be able to find the field where you specify a tag and then put a 1337 in there.
It sounds like a consensus. Our times 1337. Time 1337. Consensus beginning one. Yes, no.
Is anyone having fun? Raise your hand if you're having fun. Look, some people are having fun.
It's kind of cool to see how it all works.
Yeah, this is wonderful. Any more questions, or should we get to coding? Dusty has a
Somebody
question.
use 1337.
Whoa, that was fast. I think it was Topher. All right, cool. People are doing it. All right. Is everyone ready to get coding and make your own Nostr app now?
Yeah.
So just do whatever you want, make something, and Topher and I will be available for questions. Topher's made his own Nostr app, and I've made my own. So if you've got an idea that you want to start working on, go for it. And we're here to take questions. Austin.
Is there any proposal to use your pub key to generate an address?
To generate a Bitcoin address?
And actually an address that you can send or receive message to. Because like the whole reason we have addresses in Bitcoin is that so we don't talk to our master public key. Is there that same kind of capability in Nostr?
To like have a master public key and then generate child public keys from that for each one?
Yeah.
No, there's no such proposal. You should come into our group. Yeah, you could.
So you don't talk to your phone number.
By receiving messages.
But then you can also still use that same color credit key pair to receive messages, but not dox your phone.
Like stealth addresses, but on Nostr. Maybe. Yeah, I think so. Probably.
Could also use your LN address.
Yes, I think so, because your LN address is connected to your node, which has a pub key. So you could use that pub key for this. You can stop the recording.
Okay.
And we're done. Get to work. Oh, great.
There are a lot of strings in it though. I didn't realize how like Plato is. Like you can do all these really cool things.
Yeah. It is a wonderful protocol.